So we're just going to have a test tomorrow.
Right.
You're up for that?
Yeah.
So it should be, I think it's going to be probably too easy. So just the product, chain, quotient rules, and tangents. For the product rule, you have to do the development of the product rule.
Right.
And I put a little image that shows you what the product rule development is.
Okay. For the tangent to just like find the equation?
Yeah, so it might be, basically, what's the equation of a tangent at such and such a point on the curve? So might involve, it might involve finding the derivative, and you'll probably have to use like the chain or the quotient, or the product rule. So it should be pretty straightforward, I think, anyway.
Yeah.
All right, you up for a little bit of for a question?
Sure.
Bit of review. Okay. Here we go. Got a question for you. Maybe you've seen it already. At least I hope you have. Okay. There we go. How's that look?
Is it number 7 or 8?
Well, let's do number 7A first.
Okay.
Ignored all this. What's the derivative of that?
Half of that takes on negative half.
Yeah. And then we just leave all this junk in here. Now I do the derivative of the inside, and what do we get for the derivative of the inside?
2x plus 2.
There. Does that make sense, Luke?
Yeah, I can't see the board, but
Ah, okay. sorry. Bit of a neophyte. Yeah, sorry about that. Okay.
yeah, I had. Oh yeah, I forgot to explain.
Oh, okay. All right.
It's a negative half. Correct do that.
Yeah, there we go. Right. So that all makes sense?
Yeah.
Okay. Good. And I guess if we want to rewrite that, we just do it up here. So f prime of x, 2x plus 2 over 2 square root x squared plus 2x plus 8. So there's our derivative. What do I do to find the slope of the tangent?
You set 0 or do you set to the x?
So RJ thinks, he wonders if you set it to 0 or set it to x. Luke, what do you think?
Don't you sub in x?
So you sub in, yeah. So we're going to substitute the x coordinate of the point where we want the tangent. So we're actually going to go f prime of 2, Wow, there's a lot of 2's in this.
Oh, did they all cancel?
I did a quick investigation and they didn't. However, they do make a nice square root here, so. Two times 2 is 4, plus 2 is 6 over 2. And this whole thing in the square root. That's 16, isn't it?
Yep.
Nice. So it's 3 over, so our slope is 3/4. And how you want to find the equation of the tangent is completely up to you. But the point slope form is the easiest one. So y2 minus y1 is equal to the slope times x2 minus x1. So y minus 4 is equal to 3/4 times x minus 2. So this is one of those questions where they've already calculated the y-coordinate for us. And if that y-coordinate hadn't been given to you, RJ, what should you do with it? How should you find out the y-coordinate? Luke, any ideas?
How to find the y-coordinate?
Yeah, if they just said the tangent when x is equal to 2, how would we figure out the 4?
Wouldn't you sub x into the original? And
Just
then
exactly. Yep.
find y.
Exactly. Yep. So they're giving you more than you need to know when they tell you 2 and 4, because you can always just calculate the 4 from the original equation. Okay, so that's the equation in point slope form, but you could, or 2-point form, but you could solve that for y equals mx plus b. Okay, good. I've got one more question. Let's go to, this time I'll try and get my screens right so that Luke can actually see what I'm talking about. There we go. Okay, it's question 8. It's a little bit more of an abstraction. So they're telling you the value of some functions, and they're telling you the value of some derivatives, and they want you to figure out the value of the derivative at 2. So first thing, let's just do 8a. What should you do first, RJ?
I'm recording all the numbers right now.
You're putting all the numbers down? Okay.
It's kind of hard.
Are they hard to see?
That's because I only have half screen.
Like, you've only got a half a screen?
I only have mine at half screen, so if you look at some, I can.
Oh, I see. Okay.
Now it's full screen. It's actually oops.
Any ideas how to do this bad boy, Luke?
Well, it really changed a little bit. I'm not sure where to start. Like, maybe something like, I don't know.
Yeah, so this is, you're right. We're going to be using the chain rule. All right.
You just plug everything in.
So basically, yeah, this one it's kind of a leap of faith one, but essentially you're going to do the chain rule on f at x, and you're going to do it with respect to g at x. So you're gonna get f primed at x in terms of everything that's on the right hand side. So just do the chain rule on g at x to cube, and tell me what you get. So let's take like 1 minute. Tell me what you get when you take the derivative of g at x to the exponent 3 using the chain rule.
Like the derivative of f,
Yeah,
prime.
yeah. Sorry, Luke, can you see that, or do you need it?
No, I remember what it was. Sorry.
Okay.
I remember.
All right. Any ideas? Just doing the derivative like that, Luke, what does it become?
Isn't it just like inside?
Yeah, if we just do the derivative of the outside function first.
Oh, 3 brackets gx to the power 2.
Perfect. And then the derivative of the inside function is just
G of x.
Alright,
yeah. Yeah. So we actually just write it as g primed of x.
I wasn't sure if it was that or if it was just x. Because when you take the 1 down.
Right. But we take the derivative of the inside function, and they gave us a bunch of information, right? So they've told us what g at 2 is. So f primed at 2 is just going to be 3 times g at 2 squared times g primed at 2. So if we just read out the values, what's g at 2? It's 4, yeah. And then what's g primed at 2?
-1.
-1? Okay. So 3 times, it's going to be negative 42. Did I do that right?
48.
48. So that's 16, 3 times.
32, 48.
Right out on the internet and everything.
This is
Oh, look at that. That's okay though, because
This is
nobody
perfect.
saw me because, of course, I wasn't sharing. All right. Good. So I think those are pretty much as hard as it gets. Sound all right?
Yep.
All right. That's good. So I think I'll leave it at that, and we'll probably see you tomorrow, Luke. We'll try and get started right at about sort of 2 o'clock. Or
Okay.
It's gonna take me till 10 after 2. I don't think this test is gonna take very long, though. It's probably gonna be 40 minutes, maybe at the outside.
Alright.
Sound good?
Yeah.
All right.
Yeah.
Good. Any questions?
No, I don't think so.
Okay, good. I should have kind of what I'm putting into your report card. Actually, I'll just send that message to you tonight, probably.
Alright.
All right, good. We'll see you.
See you guys tomorrow.
Yep. Bye, Luke.